So now let's do the plotting. What we are going to do now is we are going to do the plotting of these two arrays only. But now we have seen that how we can plot, like how we can draw one graph. Okay. Now what we will be doing, we'll be creating two axes, and this is called the inset graph. What is the inset graph? So inset graph is the graph inside a graph. Can we do the plotting for such a graph? Yes. Let's see how we can do that. So we'll be creating another plot somewhere around here. So how we can do that? So we have to set the axis. Let's say if I want to create one graph here, okay, what will be the size? So I'll keep this left margin at around 0.2 unit, bottom margin at around 0.5 unit, width I'll be keeping at around 0.5, and height I'll be keeping again at around 0.5. If I'll be creating that kind of axis, then probably I'll be able to plot this graph. Okay, let's do that. So I'll be creating one figure object. Figure is equal to plt.figure. Okay, and next I'll be setting one axis. ax1 is equal to figure dot add underscore axis. In this, I'm going to set the left margin. So this is the larger one, 0.1, comma 0.1, comma 0.9, comma 0.9. And I'll be setting another axis, that will be axis 2. And that will be around, so left margin will be 0.2, bottom margin will be around 0.5. This will be, width will be 0.5 and height will be 0.5. Now let's execute it. So if you see this, it is coming this one. I'll keep this one at 0.4 unit. Okay, fine. This one also, let me decrease this to 0.4. Now I'll be plotting the graph. So ax1 dot plot. I'll be plotting array 1, comma array 2. So array 1 versus array 2, and the color I'm setting as red color. Similarly, I can do ax2 dot plot, and in that array 2 versus array 1 plot I'll be doing, and the color I'll be setting as blue. Okay, so this is array 1 versus array 2, and this is array 2 versus array 1. Clear? This is called inset plotting or inset graph. Clear, everyone?
Abhishek, this inner graph that is made, so the plotting that point 0.1 and that all this thing again is taken from the figure only, huh? The 0.2, 0.5.
From figure boundary.
Okay.
Okay. Fine. So next we are going to take is the multiple plots in a single figure. So this is one figure. In this, I'll be creating two plots. Okay. So how we can do that? Again, so for creating multiple plots, we have this subplot function. We can take figure comma axis is equal to, we have a function called plt dot subplots. Okay. So what is the advantage in these subplots is, when you use subplots function, you don't have to add the axis explicitly. Okay, it will be taking the axis automatically. So if you'll be executing it, you'll see these axes are added automatically. What is the margin? That is set automatically. We are not going to interfere into that. Okay. So the advantage of this subplot is you don't have to set the axis explicitly, and now you can do the plot here. So to do the plot, again, we'll be doing axis dot plot, and here we'll be plotting array 1, comma array 2. Execute this, and this is the plot of array 1 versus array 2. Now this subplot, using this subplot function, I can do the multiple plot. So for example, figure comma axis is equal to, I can use plt dot subplots, and here I can mention n rows is equal to 1 and n columns is equal to 2. What it says, number of rows and number of columns. Now with the axis, I can set the plot, but first of all, let's see how many figures are added. Here you'll see that 2 figures are added. What I said, see, in this plot, this is called the rows and this is called the columns. So in this, I have created 1 row and 2 columns. I can create multiple plots, for example, 2 rows and 2 columns. Okay, fine. Okay, you can create 3 rows and 2 columns. Fine. We can create 3 rows and 3 columns. Okay, so you can mention that how many rows and how many columns you want with the end rows and end calls attribute into the subplots function. Clear? Fine, everyone?
Yes.
Okay. Now, in this, if you want to do the plotting, so there are 2 axes created here. Okay. If you will be printing the axis, then it will show this list of the axes. Okay. You can access this array of the axes. So you can access this axis using the indexing. Axis 0 will give you this one and axis 1 will give you this one. So if you want to plot, you can say axis of 0 dot plot function, and you can plot here array 1 comma array 2. Similarly, axis of 1 dot plot, you can say array 2 versus array 1. Okay, fine. Clear, everyone?
Abhishek, this thing like in plot function we are passing 2 arrays, right? Array 1, array 2.
Yes.
So this I am not very clear. Can you please
This
explain
array
once
1
more
and
why
array
we
2
are
we have
passing 2?
defined explicitly, array 1 and array 2.
Yeah, array 1, array 2 will define, and then this 7 is clear. If you can come back at eighth cell, just can you scroll down?
1 minute. Yes, where?
Uh, can you scroll up? Yeah, the one above this one. This one. Yeah, ninth cell.
Hmm.
So here we created a subplot, and then we passed axis dot plot 2 arrays. We passed it array 1 comma array 2.
Mm-hmm.
So why we are getting only one line?
So we are plotting array 1 versus array 2. On x-axis, we are plotting array 1, and with respect to every value of array 1, we are plotting the array 2.
Okay, so here the two axes are represented by our 2 arrays that we declared, and then the comparison between the two.
No, 1 minute. See, where here, if you'll see, we are plotting array 1 versus array 2 in this graph. Okay. And we have only one axis. Here we have 2 axes. In these 2 axes, here also we are plotting array 1, array 2. Here also we are plotting array 1, array 2. But the difference is in this graph, we are plotting array 1 along x-axis. We are keeping array 1 along x-axis and array 2 along y-axis. Okay. You
Okay.
can set the x label and y label. Axis dot x label, and here you may say array
Array.
1. Okay,
Okay.
along the x-axis you are plotting array 1, and along y-axis you are plotting array 2. Okay, okay. So if you see here array 1, array 2. Okay, and
Okay.
if you'll see here, so in axis of 0, in axis of 0 dot set underscore x label, we are plotting array 1 along x-axis, and we are plotting array 2 along y-axis.
Okay.
Okay. Similarly, in the axis 1, here we are plotting array 2 and array 1. So we'll execute this array 1 versus array 2 versus array 1. Clear?
Okay. Yeah, so one more final question. So here x is 0 and x is 1 are representing our two subplots.
Yes,
So
two subplots.
X is the, and what if in the PLT dot subplots, if we have suppose n rows 2 and n columns 2, like in total it's
Then you will be using multiple indexes. For example,
okay,
two rows and two
indexing like
columns. Yes, we have, correct. Now access
yeah,
of this is 0 rows. Okay, this is 0 row, this is 1 column.
second column.
This is 0 row and 0 column and 1 column. So this will be 0 comma 0, right? So here you will be writing 0 and 0 of 0. 1 minute.
Okay,
0 of 0. This will be also 0 of 0. This will be also
okay.
0 of 0. Okay,
Yes, Abhishek,
right?
understood. Thank you.
And here
Yeah.
it will be 0 of 1, 0 of 1. Okay, execute this. You have got this two plots. Now, rest of the things, this one will be represented by 1 row, 0 column,
1
1 row,
0
1
1
column.
1.
Yeah,
Yeah,
clear?
thank you.
Anything else, guys?
Abhishek, can we use 2D or 3D arrays over this?
Yeah.
2D or 3D arrays to
Yes, yes,
plot
you
the
can,
graph?
you can plot anything. You can plot any array.
Okay. So can we take one example of 3D array over here?
Let's take 2D array. 2D array will be too much complicated. Okay,
Okay.
let's take the 2D array. Array 3 is equal to np dot arrange 20 comma 30. Okay, and we have 10 values, so I'll be reshaping it. Reshape 5 comma 2 array 3. Now access of 1 of 0 dot plot array 1 comma array 3. Same dimension. So how many element we have in array 1? 9. Let's do one thing. Array 4 is equal to np dot arrange. Sorry, let's do one thing. Array 3 dot array 3 into 2. I'll be plotting now array 3 and array 4. Have this. Okay, fine. It is a linear graph. If you'll be taking to the power 2, then it will be not linear. Let's execute this. It is bit tilted. Okay.
Yep. Okay.
Okay. Now, so we have seen that how we can do the multiple plot, subplot. Basically, we can create in a single figure. Now, if you see here, these points are coinciding. So to avoid this, we have a function called plt.tight underscore layout. plt.tigst underscore layout. Okay, this will avoid the coincidence of the graphs. Okay, fine. So this is about the different ways you can do the plotting, and this Matplotlib is mainly used for plotting the arrays, NumPy arrays. Okay, to do the plot for the data frame object, we use the different like we have the Seaborn. There we can do the plotting of the data frame objects in the using the Seaborn. We don't use Matplotlib for that. So if you want to do any plotting of any column in the data frame object, you have to convert it in the array and then you can do the plotting. But most of the categorical plot and all we will be doing using the Seaborn only, okay, of any data frame object. So now what we will be looking at is at the different attributes, how we can control a figure like figure size or aspect ratio or the DPI into of a Matplotlib figure. Okay, so for example, if you want to set the figure size, as of now the figure size is too smaller. If you want to set the figure size, so we have the fig size attribute. Okay, so we can use figure comma axis is equal to plt dot subplots. Okay, and in this we can add the fig size attribute is equal to we can write the 12 comma let's say 8. Okay, and there is DPI attribute also which says the pixel of your image. Okay, so now if you'll be executing it, so fig size DPI equal to, okay, so this is quite a larger plot we have now. Okay, we can add the n rows and n col attribute also. For example, n rows equal to 1 and n cols is equal to 2. So this is the plot we are going to get. Now here you can do the plot accordingly. Okay, fine. So this is where you can set the figure size and the pixel of the graph. And also you can save this graph. So if you want to save the graph, what you can do is, let me do one thing. I'll be plotting the two graphs. I'll be using axis is equal to, axis of 0 dot plot. I'm going to plot array 1 comma array 2, and we can do axis of 1 array 2 versus array 1. Execute this. So this is the plotting we have done. Now this is the figure, and on the figure attribute we can call the save fig function. So we can write fig dot save fig function, and we can give a name here. So we can write let's say demo.jpg. In any format you can save, JPG, PDF, or PNG, in any format. So once you'll be executing this code, you'll see that with this name, one image will be saved into this default location. Where is this demo.jpg? Let's find it, demo.jpg. This is what the figure we have. Okay, fine. Okay, so next we have legends and labels. Okay, what is legends and labels? So in any graph, you will find the legends and label. This is called the this whole square bracket which you can see. This is called the legend, and these all are called the labels. Okay, so we can set the labels and we can set the legends also. How we can set the legends in a graph? So to set the legends in the graph, we have legend function which we can call on the axis, and we have the label attribute which we can call on this. So let me do one thing, just copy it, and we have the label attribute. So whenever you are plotting the graph, you can set the label is equal to the value which you want to show. So here you are plotting array 1 versus array 2, right? And here label is equal to array 2 versus array 1. Okay, fine. So this is the label, and then we can set the legend. So to set the legend, we have axis dot legend. Okay, when you'll be calling this legend function, so this legend and labels will be shown at the top of the graph. LEGENDS, legends. this one. Okay. So you have to you have to call this legend function on every access value. Why? Because for every plotting, you'll be getting the different legend and label, right? So you have to set on access 0 and access 1. Let's say if you had this graph, let's say if you had this graph, where you have only one plot, okay, and then you would have plotted access dot plot array 1 comma array 2 comma label is equal to array 1 versus array 2, okay, and you'll be having color is equal to red. And similarly, you'll be having another plot array 2 versus array 1, and label is equal to array 2 versus array 1, and this color is going to be green. Okay, now execute this. Okay, remove this. We'll set the color attribute later. Okay, we have these two plots. Okay, automatically it is taking the color, so that is fine. Now we'll see how we can set the color later. But as of now, we have set this, and if you'll be now writing access dot legend, then you'll see that it will show this legend at the top in the square bracket, and it shows with the color that which one plot is for which graph. Okay, fine. So we can set the legend and label this way, as well as you can set the position also where you want to keep. So if you'll be writing 0 in the legend, access dot legend, LOC equal to 0. So this takes the best position. Writing 1 will be keeping it in the right hand side top corner. Writing 2 LOC is equal to 2 will be keeping it in the left hand side top corner. 3, if you'll be writing 3, then it will be taking the left hand side bottom corner. And if you'll be writing 4, so it will be taking right hand side bottom corner. Taking 5, it will be taking right hand side middle, and writing 6 will take it as left hand side middle. 7, right hand side again middle. Let's see 10. I think 10 is in the middle. Yes, 10 is in the middle. But if you'll be writing 0, then it will be taking it in the best possible position where it is not going to coincide with the plots. Okay. So either you don't mention the LOC, which will be taking the default position, and if you'll mention LOC equal to 0, so it will be taking the best suited position into the graph. Okay. Fine. Okay.
So, for drawing these visualizations, in real world scenario, do we use this, or we rely on Tableau tools like Tableau, Power BI?
Tableau is for creating the dashboard, okay. But when you want to do the analysis initially, that is Tableau is your final thing. Tableau creation, the dashboard in the Tableau is the final thing, okay. But let's say if you want to do some data analysis and you are a Python developer and you are working on the Python part in the data science team, and if you are given with a data set to do some analysis, then you'll be using these Matplotlib Seaborn and all these things, okay, to visualize. Tableau will be the final. You'll not be using Tableau at the very beginning, right?
Okay.
Okay. Next, what we have, we can set the color parameter, line width, and line style. So to set the color, line width, and line style, we have the color attribute, LW attribute, and LS attribute. Let's see how we can set all these values. And also there is a marker attribute. Okay. So let's see how we can set this all. So Okay, now this is the plot. In this, we are going to plot axis dot plot function, and in this we are going to plot array 1 comma array 1 plus 2. Okay, this is a linear line. Similarly, we'll be plotting array 1 plus 3 plus 4 plus 5. Execute this. We have multiple plots. Okay, now we can set the color attribute explicitly. We can set the color equal to, let's say, red, green, or blue, anything. Okay, I can set the color red for the first plot. This will be green. This will be blue, and this will be yellow. Okay, execute this. So you have red, green, blue, and yellow. You can set the line style. LS is equal to, LS stands for line style. I can set the LS is equal to colon, which will be a dotted line. I can set the LS is equal to LS equal to a dashed line. Okay, and we can set the LS is equal to dashed and dotted line, and we can set the LS is equal to continuous line also. Okay, execute this. We have 4 types of line. One is dotted line, red color one. This is the dotted line. This is the dashed line. This is dashed and dotted line, and this is continuous line. Okay, using LS attribute. We can use line width. LW is equal to, line width can be any value. So I am going to give, let's say, I'll be giving, I can give some smaller value, 0.25. LW I can give some higher value like 1. Then line width I can give some 5. And what if I will be giving line width is equal to 10? Let's execute it. So if you see 0.25 is so small value that it is not visible. 1 is quite visible. 5 is bit thicker, and 10 is more thicker. Okay, we can use that. Similarly, we have the marker attribute. So marker attribute, you can use the different markers. I can use the plus, or I can use the dots, okay, O, or I can use the marker as S or L, anything, okay, and I can use the marker as 1 also. What all the marker attribute you can have? So you have, these all are the different marker values you can keep. Okay, keeping O will be giving you circle, V will be giving you down arrow, this will be giving you up arrow, this will be giving you left, this will be giving you right, and so on. Okay, fine. So these all are the different values. So if you will be executing it, so you'll see that these all are the different markers. We have given plus, we have given dot, we have given the S, which is, S is what? If you'll be seeing S here, what is S? S is square. So S is square, okay. And since it is bit thicker, so it is not visible. Let's keep 1. Now, 1 is, I think, 1 only. If you'll keep a number, 1 is this triangle down, okay. So if you'll see it here, it is the, if you cannot, yes, this is this way, okay. You can see it here, triangle down, okay. Fine, everyone.
So wherever our X and Y axis are meeting, that point is marked with the marker.
Yes.
Okay.
Anything else?
Abhishek,
Hmm.
will this be this same kind of graph only we can do in Matplotlib, or we can do different kind of graphs?
Different kind of graphs means which
Like
kind of graph?
instead of that line graph.
You can see you can do multiple graph also, like box plot you can do, categorical plot you can do, or bar plot you can do. Okay, Valiant plot you can do, but it is not used for that. Okay,
Okay, okay,
Matplotlib is not used for that. Why? Because it is not convenient. You cannot control the different attributes of a plot when you'll be using those plot in the Matplotlib. You have very minimal control over that.
okay, okay.
So for that reason only we have the Seaborn. And if you can do the plotting also, you can do the plotting of only the NumPy array data. But you know that most of the data we're going to use in the data science field is going to be the data frame object, which you cannot plot using the NumPy, Matplotlib. For that we have the Seaborn.
Okay, 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 Abhishek. Thank you.
Okay. Anything else?
So Abhishek, one thing was like, is there a way to like maybe show the actual values wherever the axes are like placed on the lines, like something, some sort of a tooltip maybe or something,
Sorry.
a tooltip maybe on the graph. Is that possible here in Matplotlib?
No, I didn't get what you are saying in the beginning.
So like suppose if I hover on these marks, is
Oh,
there a
okay.
way I
No,
can
no,
see a
no, no.
tooltip or
Those
something?
tooltip and all is not available here. We have those options in the other modules.
Okay.
Okay, that is what. So you have very minimal control over here. Okay.
Okay.
Anything else, guys? Any other question? Okay. So this is it about the different attributes in the graph. Okay. And there are some other plots also, but we are going to do those plots into the Seaborn, so we'll not discuss here because the advanced plots we will be not doing at all into the Matplotlib. And also, whatever case studies and everything we'll be doing, most of the things we'll be doing using the Seaborn or the some other module. Okay, most of the plots will be doing using the Seaborn module only. Okay, so we'll be learning the Seaborn now. So I'll be keeping this discussion till here for the Matplotlib, and I'm going to now move to the Seaborn.
Abhishek, I have one question before we move on to Seaborn. Okay. Yesterday, you mentioned before starting Matplotlib that we are going to follow the object-oriented approach,
Yes.
right? What are the other approaches we have for Matplotlib?
We have the functional approach also. We don't use that.
Can we see one example just to understand?
Yeah, sure. Let's see it here. Okay. So instead of creating the figure, we can directly use the plot function. Okay. So as of now in the object-oriented approach, we are creating the figure and axis, right? We can use directly the plot function. For example, we have the plt.plot function, and we can do the plotting of anything. So array1, array2, and it will be plotting the graph. Okay. You can set the x label and y label also for this plot. So you can write plt.x label. Okay. And we can write here array1. Similarly, you can use here array2, and title you can set here as array 1 versus array 2. Okay. Execute this. Clear? Array 1, array 2. This is going to be while. Okay. And if you want to do the multiple plots, so here we had subplots function, subplots. Okay. And here we have plt.subplot. Okay. And you can pass the number of rows and columns here as well, 1, 2. This one will be the graph. Okay. Which graph you are going to plot. 1 row and 2 column. And you can also write, this is 2. We have 2 plots here. And here we can do the plot of plt.plot again. And we can plot array 1 comma array 2. And here we can do plt plot of array 2 versus array 1. Okay, fine. Here we don't have, like, if you want to access this plot, so you have to give a number here. 1 is pointing to this graph, 2 is pointing to this graph. Okay, if you have multiple, then you have to give 1, 2, 3, 4 and all. Fine. Clear? You don't have for which graph you are accessing. Here you can access every plot using AX attribute or using the axis object, right? Axis 0, axis 1, axis 0, axis 1. We are accessing this way. But here you don't have. You have directly plt.plot or plt.subplot function. Okay.
Okay, thanks, Abhishek.
Abhishek, little bit you can go above. Yeah, this one. Okay. Okay, fine. Yeah, thanks, Abhishek.
Okay, so now we are going to move to the Seaborn. In the Seaborn, we are going to do the different other types of plots, like categorical plot or the linear plot or the what else? There are different types of plots. Let's see which all plots we have here into the Seaborn. We have the different types of distribution plot. We have the how we can find the linear relationship between the different plot. We have the how we can do the categorical plot using the box plot or the using the Valiant plot and all. So those all plots we can do in the Seaborn. And Seaborn is also useful when you have a data frame and you want to plot the data related to the data frame. Okay, let's see how we can do that. Just
So, Abhishek, using Matplotlib, we cannot use DataFrame or.
No, we cannot do the plotting of the data frame.
Okay.
Just a second, let me see one data. Okay. So first of all, installing the Seaborn. So to check whether the Seaborn is installed or not, we have we just need to import Seaborn as SNS. Okay. Seaborn import Seaborn as SNS. Now, This is the Seaborn library we are importing. And SNS is again used acronym. What we are going to, what type of data set we are going to take here is, we are going to take a data set, car crashes. No, not car crashes. Let's take a Pokemon data set. So let me see where the data set is. Not here. Not here. 1 minute. So we are importing this Pokemon data set. I have kept it here into the data set folder. Okay, and we have the different columns here. So let's analyze this data here, which is the name column, type 1, type 2, total point, health point, attack point, defense point, special attack point, special defense point, speed point, and generation. Out of these, we have few of the columns which are the numerical data. Few of the columns are categorical data. So may I know which one column are the categorical and which one column are the numerical?
Name, type 1, type 2 are categorical.
Okay. Name is also categorical?
No, name is not
No.
categorical.
Generation is also
Type
categorical.
1, type 2, and
Type
Generation,
1 and type 2 are categorical data. Total point to speed point are the
numerical,
numerical data.
numerical, and generation is categorical data. Okay.
categorical.
So how you will find whether a column is categorical column? So if you have a fixed set of value, then it is a categorical column. Okay. Here also you have a fixed set of values. Here also you have only one single value. So this is the categorical. Rest all the numerical data. Now what we are going to do here is, let me just plot dot head. Okay. So we are going to do the categorical plot for this. Before categorical plot, we are going to visualize the different distribution, how the data is distributed. Okay, like if I want to see how the attack point is distributed or how the defense point is distributed, means between which range the most of the Pokemon character are having the attack point. Okay, whether most of the Pokemon character are between 50 to 80 or 30 to 100 or 30 to 90 or 30 to 60, that we want to find the distribution. How we can find that? So to find the distribution plot, first we are going to get the distribution plot, and in the to find the distribution plot, we have the dist plot function. Okay, so we need to import few other module also. Let me import numpy as np and also import matplotlib.pyplot as PLT. Okay. Now, to find the distribution plot, we have the sns.distplot function, and in the distplot function, we can pass the argument whichever column we want to plot. This is the univariate analysis. We are going to pass only one single argument. Okay, we want to plot attack point. Okay, so we will be plotting the attack point Pokemon of attack point. Okay, and then we can set the x level and y level also to, or we can set the title. So to set the title and all, so let me plot here d_plot equal to this. Now d_plot to set the title, we have set underscore title. Okay, point distribution. Okay, and d_plot dot set underscore x level. Similarly, we can write set underscore y level. Here we can write attack point, and here we can write frequency. Execute this. Now we have the distribution plot of the attack point versus the frequency. Okay, which says that most of the characters are having the attack point between around 25 and 50, around 35 or 30 to, you can say, 100, right? Clear? Fine. Or you can say the higher one is this one. Okay. Now here we have two plots. One is the KD plot, one is the histogram plot. Okay. If you want only the histogram plot, then in this we can set the KD equal to false. KD equal to false. Here I'll be writing hist plot. Okay.
What is that KDE?
1 minute. Okay. Now, what is this KD? KD is the kernel density estimation, which is again the statistic term, which you'll be learning that how to find the KD curve in a data or in a plot. Okay. Clear?
Abhishek, I'm getting error like module Seaborn has no attribute this plot. Why is it so?
DISTPLO.
This, okay. Got it.
Okay.
Yes.
Fine. So
Yes.
we have this distribution plot where we have set the KD equal to false. If you want only the KDE graph, not the histogram plot, so you can write KD hist is equal to false. Okay. Fine. You have the KD plot here. Clear? Fine, everyone. Any question, guys? Okay, next we have the color attribute also. For example, if you want to set the color attribute, you can set here color is equal to red. So we have red color. Okay, you can set any color. And there is a rug plot also. What is this rug plot? Rug plot basically gives you the every individual point of the attack point. If I will be setting the rug is equal to true, let's say in this plot, if I'll be setting rug is equal to true, in that case it will be giving you the rug plot. Okay, rug is equal to true. In this case, it will be giving you the rug plot. What is this rug plot? So it is giving you the individual point wherever your attack points are there. And from this data also, what you can observe here is that most of the data are scattered around this point only. Okay, fine, clear? Any question, guys?
No.
Okay, now in the wherever you are getting the hist plot, okay, you have this histogram plot, right? In this, there is a bin attribute. You can set the bin to some smaller or the higher value. Okay, if you'll be setting bin is equal to 10, or if you'll be setting bin is equal to some higher value. Okay, let's observe the difference between these two plots. Bins, or okay, so if you are setting the bins values at some lower, bins is equal to 10, and if you are setting bins is equal to 80, then what is the difference between this? So basically, bins divides the entire range of values into a series of intervals. Okay, and with the higher value of bins, the larger variation in the histogram can be seen. means for individual point, you can see the variation into the data. Okay, so if you want to see the variation into the data for individual point, you can keep on increasing the bins value. Okay, if you lower the bins values, then the variation in the data will not be quite clearer. Correct? Fine. It will show you the range, that in this range, most of the data are, or most of the Pokemon data are having the attack point, like, three Pokemon data are having the attack point around 20 to 40. It is showing you the range. Okay. But here it shows that one Pokemon character is having around one Pokemon character is having 20 attack point, one Pokemon character is having around 25, one is 30, one is 35, one is 40. And around 5 Pokemon characters are having more than 40 attack points. Okay. Around 4 Pokemon characters are having around 80 or little less than 80 attack points. Okay, so we can see the variation into the data easily with the higher value of bins. That is possible into the histogram plot. Remember.
What does that 80 represent here? 80.
What is?
What does that number 80 represent?
80 is the variation. Like if you'll be taking the higher value, okay, it will be showing you the higher variation. If you'll be taking the lesser value, it will be showing you the less variation. It is just a number, a parameter which says that what kind of variation we are going to see into the graph. Okay.
So 80 means basically it is on the x-axis 80 intervals would be there.
Not exactly. 20 to 80, it will be 100, right? But we have more intervals.
Yeah, but for if you go above there, you may be able to see like the bins are 10, so the interval would be like 10 intervals, right?
This one you are saying? This one?
Yeah, basically the intervals. It doesn't matter if it does not have any data, but
Yes,
10.
So in that case, this should have 80, right? So how many intervals? 1, 2, 3, 4, 5.
There may not be data in those intervals. Suppose if there is a gap, it means that that interval does not have the data. So like here 110 to 120, there is an interval there, but it does not have any data.
Yeah, no, see this, the 10 and 80 is not like that. It is not showing the interval. It just shows the variation. Okay, it is not like that.
What do you mean by variation? I did not get that.
Can you give some 150 or something like that?
The variation in the graph. What do you mean by variation? How the data is varying, right? That you will be able to observe with the higher value of bins.
Yeah, that I understood, but basically bins would say that in that particular range, what is the variation? So using bins, we could like see that in particular range, how much is that data which we have plotted.
I don't understand.
That is basically like when we plot a graph, when we plot a histogram, we use bin as ranges. So we can.
If you want to bring out something, you can say anything for your understanding. Okay.
No,
but
I'm just trying to understand that if 80, what we are mentioning there, 80 or 100, what does that mean? I'm not clearly understanding that. From what I understand, it is the interval of data. So 80 intervals should be there.
80 intervals means how you will be counting the 80 intervals? Tell me. Either you will be counting from here to here 140, so it is more than 80 intervals. Okay, and if you are counting these individual points also, then also it will be less than 80.
So basically, how it would be, suppose it is from 0 to 150. So that 0 to 150 would be divided into 80 equal parts.
80 intervals, correct.
Yeah. So that's what I'm saying.
No, I didn't find any such definition of the bins anywhere.
So
I have
is it that
checked
the data is put in 80 bins and
Yeah, like generally that's what like
Deepak, just a second. Let me discuss with Saran, then I'll be coming to. Yes, Saran, go ahead.
so what I was getting from this was that suppose the x-axis is suppose 150 and you are writing their bins equal to 80. So that 150 is divided into 80 parts.
Yes, I understood what you are saying. So basically, let's say when we do the plotting of the graph, so if we have the axis drawn from 0 to 10, so and we have to divide it into the 10 equal parts. So then we'll be taking 2 equal parts or 10 equal parts, right?
Yeah.
Correct. We'll be dividing the graph into the 10 equal parts or 5 equal parts. So we'll be getting that. But that is not exactly the mean here of the bins. You can see the definitions of the bins into the, let's say, if you type here bins in Seaborn dict plot, okay. What are bins in Seaborn? So histogram represents the data of bins along the range of the data and then drawing bars to show the number of observations that fall in each bin. Seaborn comes with some data set and we have used few data set in our previous chapter. So leave it. That is what, how do you create a bin in Python? Not here as well. Let's see in the Seaborn. You don't have it here.
So we could just like instead of 80 we would like write 100 there, then you would see like even more ranges there. That's
Yeah, obviously you will be able to see the more ranges. That's what I'm saying. So you are saying more ranges, but I'm saying more variation. That is the proper definition of it. Okay. Obviously you'll be able to see the more ranges. Okay.
so we are able to see
larger
more
variation
variation because the number of ranges are increasing. Suppose if we want if we want to show like 100 equal distribution, maybe we would write the bin as if they are equal. Like suppose if there are 150 points, then we write 15 bins. Then there would be equal of
Grouping
data.
the data into bins of equal width, bin is plotted as a bar whose height corresponds C. Aishwarya has given a reference, so you can read this. So it's fine. You are same thing. You are saying the range. I'm saying the variation. Okay. So I'll be seeing the larger variation into the graph. That is, that is my definition. You can say it is the larger data points. You can say into the graph, or the larger intervals. You can say into the graph. Okay. So this is the posted by the Aishwarya. The same thing.
Abhishek, actually, if we see here at 3, 1, 2, 3, 4, 4 bars I see, which are stopping at 3 basically in y-axis.
Where?
In the graph, if you see, yeah, 1, 2, 3, 4. Yeah, if it is in this form, we are understanding that like at between 50 and 60 there are 2 such bars, and at 70 there is 1 such bar, and at 80 90 there is 1 such bar. So if we go into the top and see what is happening at 3, will it give any idea?
Yeah, see, this is what if you will comparing. Let's say if you are saying 3. Okay, this is somewhere around 3. Okay.
Yeah.
And can you say at around 90, do we have any Pokemon character which is having this 90 attack point?
In this graph, it is not at all clear.
It's not visible. That's what. So this variation is not visible to me. How the data is varying, it is not visible to me. Okay, but that is quite like it is clearly visible to me into this graph. That variation of every data is visible to me into this graph. Okay. Now, if you say so, here it is saying a histogram displays numerical data by grouping data into bins of equal width. Okay, so if you will be having the numerical data here, whatever values you are taking, that is the numerical data, grouping the data into the bins of equal width. Whatever bins you'll be setting, it will be deciding, it will be dividing that data into the equal width, and then it will be plotting it. So if let's say if you are let's say if you are this is the equal width, bins means let's say if you are saying 10. Okay, so intervals again, as he's saying, the same interval, and for me the variation, what exactly does it mean? So this variation or this interval is divided into one bins. This is divided into one bins. This is divided into one bins, and it is showing the variation, like whatever Pokemon characters are coming. So around 11 characters are there which are falling into this range. Okay. But what exactly that, like, this is around 70 and 90, I can say, or 70 and 85. So around 11 characters are there which are falling around 70 and 85. Okay. But with this same thing, 70 and 85, if we'll be taking it 70 and 85, you have few of the characters which are coming around 1 also, which was not visible here into this. Okay. This variation I was not able to see here, whereas I was able to see it here when the bins are higher. That's what I wanted to make my point. Okay. So Saurabh point is also correct that it will be dividing it into the equal intervals. So that's also fine. It is dividing it into the equal intervals of the bins. Okay.
Yeah, so basically if we want to see a much detailed picture, we could like increase the number of bins.
Correct.
And if we want to see a summary, like we could
use the lower number of bins.
Basically, like when we see a cricket match, we see like a number of runs scored, maybe in bins like 0 to 10 over, 10 to 20 over. Like.
Correct.
Yeah. Can you once show me the data frame for this, please?
Yes. You want the whole data frame?
I think from which this is the one which we plotted the.
Yes. This is the attack point.
Yeah, attack point 49, 62, 82, 100. Okay. I have to see this.
So if you see the whole attack points, there are the different variations. 150, above 150, we have very few values. Okay.
Okay.
Yes, Deepak, you were having any question?
So basically, if there are 1,000 records and if we give the bin as 1,000, it will have 1,000 lines, right? Vertical lines.
How many points we have? It doesn't mean like that. We have 56 points. We have given 100, but it is taking the 100 value. It is not dividing into the, it is not giving you the 100 points, right? Correct? If you have lesser data, you have only 56 data. And if you are giving 100, it cannot divide the 56 data into the 100 data, right? It is just the interval. In like, what Saurabh said, you can say it is the interval, or for me, it is the variation in the data. Okay. It represents the variation in the data. Anything else, guys? Any question? Okay, let me do one thing. Let me set the rug is equal to true here. Okay. Now, if you will see this, so for around every data points, we are able to see the variation. Whereas in this case, was it that clearly visible? No. Okay, rug is equal to true. So you have few clustered data here, and what exactly every data, like what is the frequency of every data, it is not visible here, right? Whereas it was visible in this case. Fine. So this is what the variation I'm talking about. Okay. Fine. So if you want to see for individual point, if you want to see the frequency, or if you want to see the plot, then you can keep the higher number of bits, or else you can keep the lower number of bits, where the for individual point the variation will not be shown into the plot.
Abhishek, is there any maximum or minimum range for this bin value?
No, you can take anything.
Okay.
But I think system will adjust on its own to the optimal value, maybe whatever the number is.
By default, it will take you some optimal values. Okay. The variation is like, the 12 one is vanished now. The one which we are having 12, it is vanished. So for taking higher values also, this is not going to help you. So let's say take around 150. Okay. Now, if you'll observe here, this plot, this plot, this plot, and this plot, which you are getting, it is clustered together. And if you'll increase the bins values, this will also again will be plotted individually. Let's say if I'll keep 250, then now it is coming individually. Can you see the variation now easily? Okay. Fine.
Yeah, Abhishek. Can we increase this graph size so that it will be more clear?
And set this graph size. You can increase the graph size also.
If we increase the width.
Yes.
Yeah, Abhishek, it is clearly visible now.
Okay. Okay. Now, next, what we have.
Abhishek, can you just scroll up that one, just about that size, the changes you made for that? Okay, yeah, thanks.
Any question?
Yeah, that's it. Thanks, Abhishek. Yeah, that's fine. Yeah, thank you.
Abhishek, one quick question here. To change the graph size, right? The canvas size, you made plt.subplots fixed size, right? But here we are using different object for the Seaborn. How it is changing? I mean, how it is reflecting? I didn't get it.
No, so eventually you are plotting into the figure only, right? So we have used plt.subplots function also on the to create the figure and to create the axis. Okay, and in that only whatever you will be plotting now, it will be with the SNS also, Seaborn library also will be using. So Seaborn is made on top of Matplotlib. Seaborn is not a different library. Okay, for the figure and all, you can use the Matplotlib only, figure and axis. Okay.
Okay, thank you.
Okay. Fine. Next we have to get the KD plot. We have the KD plot function. Okay. You can only use KD plot to do the KD plot. So sns.kd plot function is there. And in the KD plot, you can pass the, again, same data. This one. Okay. We'll be getting the KD plot. And there is a shade. So if you want, we can set the shade attribute is equal to true, which will give you the shaded region. Okay. Fine. Clear? Okay. Next, we have the joint plot. Joint plot gives you the bivariate analysis.
Abhishek, can we get more variations in KD plot?
More variations in the KD plot, no. You can increase the figure size and all, that we can do.
Okay.
Because this is the distribution, it is a probability plot. Okay, so it will, the graph will be the for every point you have a KD plot, and this KD plot which you are getting, it is the resultant of all the KD plot, or for the individual point, whatever KD plot you are getting, this is the resultant of all of them. It will be coming like this only. Okay, probably you can increase the size, that will be showing you the larger, okay, graph. Now next we have the joint plot function where you can pass the two variables. Okay, so sns dot joint plot, and in this you can pass the x argument as, let's say, some attack point, and y is equal to some other point. So I'll be using x is equal to attack point and y is equal to defense point. So we are plotting attack point versus defense point. This is a bivariate analysis which we are doing. So we are passing two variables. Y is equal to defense point, and data is equal to Pokemon. Okay, so this is the bivariate analysis, attack point versus defense point. This is called the scatter plot, which includes the histogram plot for this one, every variable. Okay, so for attack point, this is the histogram plot, and this is the defense. This is the histogram plot for the defense point. Okay, and this total scatter plot, which you can see, this is the attack point versus defense point, which says that attack point is more scattered around this region and defense point is also more scattered around this region. Okay, fine. Next we have the we can set the x limit and y limit attribute here into this graph. So here it is starting from 2020 and going till 140 or 160, whatever. So you can set the x limit and y limit. So you can set x limit is equal to 0:100 or 200, and similarly y limit you can set 0:200. Okay, Fine.
So Abhishek, can we show the mean, median and all here in this graph? Is there a way?
Not here. Mean, median, and all those things not here. Into this scatter plot, that is the different plot we'll be getting. Okay, box plot and all. Mean, quartile ranges will be getting there.
Okay, Abhishek, like can we use two different colors?
Two different colors for each plot. No, not for two different. This one.
Because one is attack point and one is defense point, right? So attack point one color and defense point another color.
No color for every plot you are not getting it.
Okay. Because how can we differentiate? For
No.
example, if there is one dot, yeah, the leftmost dot, sorry, rightmost one, the one single dot, so which is at 150 and 50. What does it exactly mean? Can you move the cursor there, please?
Yeah.
The 150. Yeah, that one. So that is there at 150 and 45 or 50, whatever. 150 and 50, let's say. So what does it mean?
Yeah.
There was a color attribute.
There was a color, but only one color attribute, right? So you are going to set the color for the whole graph, not for the individual one, like either attack point or defense point. Okay. So you can set the color, but not for the individual one. See, it is not a single plot. Like it is not plotting the attack point individually and defense point individually over here. It is plotting attack point versus defense point.
Yeah, that's right.
So it will be giving you one single plot only. If you are plotting attack point differently and defense point differently in a same graph, then probably it will show. So it is showing you the relationship between attack point and defense point. That relationship is shown here. Okay. Fine. Yes, this one is different. This is only for defense point and this is only for attack point. But you cannot set the color differently for these two plots. Okay.
Can you scroll little up? Can you voice? Little bit, please.
Yeah. Which one?
Input 96.
This one.
Yeah. Okay. Yeah. Thanks, Abhishek.
Okay. Okay. So finally, we have the heat map plot. Okay. So how we can get the heat map plot? So to get the heat map plot, we have to find the correlation. Okay, between the different columns. To find the correlation, we have the core function. Okay, so we have to find the correlation matrix that we use for Pokemon dot core function. That will be giving me the correlation matrix. If I'll be printing core map, the correlation matrix, okay, of one column with respect to the different columns. Okay, now if we want to plot this, then what we are going to do here is I'll be writing plt dot subplots and fig size is equal to 12,8. Okay, and in this we are going to do the heat map plot. So we have SNS dot heat map function, and in this we can pass the format object, comma. There is a Vmax attribute. Vmax is equal to, I'm going to set 0.8. Then there is a square attribute which I'll be setting as true. And then there is a anode attribute, that one also I'll be setting as anode is equal to true. Next, not and format and CMap. FMT is equal to 0.2 F and CMap is equal to, okay, so these all are the CMap is equal to CMap and let me use reds. Okay, so this is the correlation plot, and this shows the correlation between the different columns. The one which one is in the darker color, that says that those values are highly related with the total point. Okay, so total point is highly related with attack point, defense point, special attack point, and special defense point. The respective columns, this diagonal column in every correlation plot, you are going to get one. So this always will show, this diagonal values will always show in dark color. Okay, the one which are in the lighter color, they are less correlated with each other. This is the color map, okay, which I have set as red, so it is coming in the red color. Square is equal to true, setting square is equal to true, default value is square default value set to true only, so it will always show you in these square boxes. And not is equal to true setting, if I'll be setting it as false, then these values will not show you. Okay, the return values will not show you, so I have set true here. Okay, and format is equal to .2f, so after decimal point how many values you want. Okay, I can set it as 3. Okay, so it will be giving you till 3 decimal points. Okay, if I'll be setting it as 4, it will be giving me 4 decimal point. Okay, and if I'll be setting Vmax is equal to 0.8, this gives you the maximum value of this color bar. That is 0.8 I have set. I can set it as 1 also. That will be coming as 1. Okay, fine. Clear?
Abhishek, I didn't get this correlation matrix, how it is created. I mean, on what basis we get that?
This is the correlation between the different columns. Okay, how the different columns are correlated with each other. How total point is correlated with total point. How total point is correlated with health point. How total point is correlated with attack point, defense point, special attack point, special defense point, speed point, and generation. How to find the correlation, or what is the correlation, that you will be learning into the stats class. Okay, fine.
Okay.
Clear?
I think there's a formula, right? Is that what you're talking about?
Sorry?
Is there like a formula to calculate
Correlation is
correlation?
the concept which you'll be learning, even I don't know about that.
Okay.
Okay. Anything else?
There was one thing, Abhishek, like you said initially that names are not categorical. So, so what are names?
Names are?
Names are not categorical variables, right?
No. Names, not names. So what is categorical data? We need to understand that if you have a fixed set of value, then it is a categorical data. For any column, if you have a fixed set of value, then it will become a categorical data. So these all are the different Pokemon character, and names are not repeating. Names are unique. So you have around 56 names, and that cannot be the categorical data. So categorical data where you can create a category. For example, type 1, you can create a category. Grass is one category, fire is one category, water is one category, bug is another, normal is another, poison is another, electric, ground, and fairy and fire. Okay, so these all are the different category which you can create out of type 1. For example, when you give the
But yeah, I understood that. Suppose, hello.
Yes.
Suppose we are showing top 5 Pokemon with special attack point. Right. So in that case, name becomes categorical, right? Because by name only you are going to show top 5 Pokemon. So in that case, names become categorical because you are using name to plot those numerical values.
No, see, understand that which one will be categorical, only one parameter. If names are the, let's say if you have 2 names which are repeating in the first 5 rows also, if 2 names which are repeating, then you can say name is categorical data. Because if you'll be having 100 data points, then probably you'll be finding 5 names or 10 names in total, and rest of them are repeating. 10 names are unique and rest names are repeating. So in that case, name column will become categorical. But if any value which is not repeating, it is every data is individual or unique, then it cannot be a categorical data.
Okay.
Here
Like
can type from the
what I understood was like categorical variables are like those which are can be numerical variables could be used to plot against those categorical variables.
No. Categorical will always be, remember, for example, let's say if you will take the feedback, okay, out of 5 ratings, so you take very good, good, average, bad, and very bad, correct? So you can say this is the categorical data. Okay, why? Because let's say
I got
that from 1,000 people, so the values those 1,000 people will give, it will be into this data only, fixed data values, right? It will be repeating. But if you will take the names of different people who have given you the feedback, they cannot be categorical, because every individual will be a different person, right? Clear?
Yeah, okay. Okay.
Abhishek, can you please repeat the scattered plot?
Scattered plot, okay. So in this scattered plot, see here you forget what is attack point and what is defense point and how we are plotting it. The one which you have to understand is here the joint plot, how we are using the joint plot, how we are passing the different attribute, and what is the information we are getting out of here. So the information we are getting out of here is the attack point is plotted against the defense point. And from this graph, what we can find that most of the attack point are between 50 and 100. Most of the defense point are between 50, here also are around 30 and 100, okay, or 80, around 80. Okay, so this is what, and rest all, how you how you can get the different attack points separately and defense points separately, that we will be looking at. Okay, so there are some other plot also yet to come. Let's see if we can do the plot individually. For example, let me see whether we have the hue attribute. Hue or calls. We don't have hue and calls here. Ratio, space, drop in a joint, marginal, not. No, we don't have that third dimension. We will be plotting few other plots. We'll be today only we are going to see few other plots also where we can add another dimension. For example, if you are plotting attack point and defense point, and if you want to add another dimension, you can do that. Okay. So how we'll be doing that? We'll be looking at it in the other types of plot. Okay.
So Abhishek, this joint plot is a combination of only scatter plot and histograms, or can we have something?
You can have hex bin plot also, and you can also have the KD plot in the joint plot. Let's see that. Good question. So let me write it here. I can set the kind attribute here is equal to hex plot to get the hex bin plot. Okay. So if I'll be setting here kind is equal to hex. So I'll be getting the hex bin plot. Okay, this is called the hex bin plot. Okay, so the one which is in the darker color, that also shows the distribution that most of the attack point are distributed around this point, attack point and defense point. Okay, and also we can set the kind is equal to KD plot. In that case, the KD plot will be looking like this. So this is again histogram plot you are getting here. Instead of that, you can set here KD, and that will be giving you the KD plot. Okay. Fine. There are other joint plot also. We'll be looking at it in some time into the visualizing the linear relationship. As of now, we have seen the distribution plot. We are going to visualize the linear relationship now between the different data points or different columns. Okay.
So how is the KD plot plotted here? I mean, what is the x-axis and what is the y-axis for it?
Which one? In this plot?
KD plot, KD.
KD plot.
No, Abhishek, they're down itself. Down. Yeah. No, down. Yeah. Here the upper one. This one. Yeah. How this is plotted?
This is KD plot for attack point. Only attack point. And here on this axis you have the frequency.
Okay, so that frequency is not visible to us. I mean,
No, frequency you can see it here. Yeah. Okay. So if you want the individual KD plot only for the attack point, you can use this function KD plot to plot the attack point individually. Okay. Fine.
okay.
Okay. So now we are going to do the analyze the linear relationship between the different columns. And to get the linear relationship, we have the LM plot. We can take the help of the joint plot also. And we have the regression plot. Okay. And that's it. So 3 plots now we are going to learn in the linear relationship to visualize the linear relationship. We have 3 plots. One is LM plot, another one is the joint plot, and another one is the regression plot. Okay. So what is LM plot? It is a function in Seaborn which is used to visualize the linear relationship determined through the regression line. Okay. So we are going to do the plotting of the regression plot or the linear relationship between the to find the linear relationship between the speed point and the difference point. So we will be using SNS.lm plot, and along x-axis I'll be plotting the speed point, and along y-axis I'll be plotting the difference point. Okay, and the data we are going to pass as Pokemon data. Okay, let's do this LM plot, and you have this regression line. Okay, you have plot speed point versus difference point. This is the regression line, and you can see this blue color strip. This is called the confidence interval. Okay, now wherever the thickness of the confidence interval is lower, there the convergence, the confidence interval is smaller. Okay, fine. Wherever this strip is thickening, there the confidence interval is lower. It means the most of the data are scattered around this point or this line. And wherever it is higher, the thickness is higher, the confidence interval is higher. Okay, and confidence interval is higher, it means the data are less scattered around this point. Okay, fine. Clear, everyone?
I think maybe we will get full clarity when we know statistics.
Yes, that's this regression analysis is of the ML class. You'll be again learning doing the regression analysis, linear regression, logistic regression. There it will be covered. Okay.
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 So that solid line represents an equation showcasing the relationship, right?
This shows you this is the regression line. Okay, so this regression line is automatically taken by the Seaborn, and it shows that the data are evenly distributed on both sides of this line. Okay, fine. Now in this you can add the different attribute. You can set the color attribute, call attribute, not color, column attribute. Okay, when you set the call attribute, let's say if I'll be setting the call attribute as type 1. In that case, for every value of type 1, you will be able to see one plot. So how many value you have in the type 1? So if you want to see the type 1 values, you can set here Pokemon of type 1 dot value underscore counts. Okay, you have bug, you have poison, normal, fire, grass, water, ground, fairy, and electric. These values, and these many graphs you will be able to see here. Okay, for every value of type 1 column, you'll be having one graph. And you'll be able to see, so for type 1 is equal to graphs, this is the plot. And how many value you have? 7. So you have 7 values. Okay, type 1 is equal to bug, you have around 11 values. You have the 11 points there into this. So 11 points are plotted here. Okay, fine. And similarly, you can set the hue attribute into this. When you'll be setting the hue attribute, adding the another dimension to your plot. Into this, you are going to see the for type 2 and what all values we have in the type 2. Let's see. You have poison, flying, ground, grass, fairy, and dragon. Okay, and if you see it here, poison is represented by blue color, that is coming into the blue color, and color is now added to this, and fire. So here you have two plots, like type 1 is equal to fire, and for type 1 is equal to fire, you have two values. What all values? You have dragon and fly. Okay, it means if you'll go to the data point, you will see wherever the type 1 column is equal to fire. Okay, for few values of fire, you have the flying values also in type 2, and few values are dragon value in type 2. Let's say if you have 4 data points, so 2 will be flying and 2 will be dragon. That's why it is plotting here 2 graphs. Okay, fine. Whereas when type 1 is equal to grass, for type 1 is equal to grass, you have only one value, which is poison in type 2. Okay, that's why you are having only one color. For type 1 is equal to water, you don't have any graph. For type 1 is equal to bug, you have 3 types of data in type 2. That's why it is plotting 3 graphs. Okay, fine. Clear, everyone? Any question? Any question? We can get this regression plot using the reg plot function also. So as I said, this is the second function. So using the reg plot, you can plot the different columns, and this will be giving you the same regression plot. Okay, same regression plot. Fine. So that we are getting directly using the reg plot. We are not using the LM plot. And the last function here we have is the joint plot. In the joint plot, again, we can combine the scatter plot, and we can combine the regression plot also. Okay, so we can use SNS.joint plot, and we can set kind is equal to regression plot, which will be plotting the attack point versus defense point, and it will be giving me the mix of regression plot as well as the scatter plot. Clear? Fine, everyone. Any question?
No, Abhishek.
Okay, so the last one we have is the categorical plot. In the categorical plot, we are going to use swarm plot, box plot, bar plot, and Valiant plot. Okay, swarm plot, strip plot, box plot, Valiant plot. bar plot, and rest all will be seeing into the case study. Okay. So categorical plot. We can get the categorical plot, but before getting the categorical plot, we will be using the data set from the SNS library. SNS.load_dataset set, and we are going to load tips dataset. Execute this. This is the tips dataset. I'm going to see just head. Okay, just 5. In this, we have total bill, tip, sex, smoker, day, time, and size. Only this column we have. Okay, and these columns, out of these columns, total bill is numerical, tip is numerical, rest all are categorical. Size is also categorical because we have the fixed value here. Okay, fine. So all of them are categorical data. And remember, in the categorical plot, whatever plot we are going to do here, these all plots, in these all plots, one of the argument should be categorical value. So first of all, we are going to see the strip plot.
Abhishek, where is this data coming from? Is this
from the Seaborn library? Okay. From the Seaborn library, this data set is available, and I'm importing that data. Okay. Clear? Okay. Now to get this strip plot, we have the SNS.strip plot, where one of the argument should be categorical data. Okay. So we can use SNS.strip plot, and inside this we can pass x is equal to different days, okay, day, and y is equal to tip. Okay, and data we are going to pass as the tips data. Okay, now let's execute it. So this is this strip plot we have. Okay, here we have the jitter attribute, which you can set to true, which will try to avoid the coincidence of the data points. Not exactly, but little bit. Okay, so if you want to see the individual data points, then probably you can use the swarm plot. If you observe this and this, almost the same. Okay, you can increase the figure size also. For example, you can use plt dot subplots fig size is equal to 12,8. Okay, so now the data points are a bit clearly visible, but still they are coinciding with each other at some positions. Okay, so if you want to see the individual data points, then you can use the swarm plot. Okay, swarm plot is more clearly visible. If you want to see the data individually, you can use the swarm plot. SWARM. Okay, this is the swarm plot where the data points are visible individually. Okay, fine. Now you can add another attribute to this swarm plot, and that attribute is U attribute. U equal to, you may tell, size. You can add size. This is adding another dimension. So this will now show you that how the people are coming in, how many, how the group is coming, like whether the people are coming more individually or in a group of 2 or 3 or 4 or 5 accordingly. Okay, so you can see most of the people are coming in a group of 2 into the restaurant. Okay,
Each point
fine.
represents 2 or how is it?
Sorry,
Not
point.
like that. I mean, one orange dot that represents what? One orange dot represents 2 people.
One
Of
dot,
two.
this dot represents that the amount, how much given. Okay, and it represents one customer who has given the tip, how much tip he has given.
One customer.
Yes. Fine. Anything else?
In graphs, is there a way we can know that on how many rows and columns we are performing, we are doing this plotting?
On all the data points.
No. I mean, just if somebody shows only graph, so looking at the graph, can we say these are the columns and these are the rows? Is that possible?
Means which column and which rows you want to find. Okay, so means say you want to say that this data point belongs to which row and which column, right?
No, actually, if you go to if you open the tips data frame or tips data, so it will have like a certain number of rows and certain number of columns, right? So looking at the graph, can we say that?
Okay, so means how many rows and how many columns we have plotted?
Yes.
No, not here, not in this. Okay. Fine. So this is about the swarm plot. Next, we have the box plot.
Abhishek, can you scroll up little?
1 minute. What?
The upper one. Where we use jitter function, I guess. Yeah. What is that jitter means?
Jitter is going to these points you can see, right? These points are coinciding with each other. So if you set jitter is equal to true, it reduces the coincidence of the points. Okay.
Okay.
Not completely if you have the larger data points. Okay. So if you want to see the individual points, then better to go with the swarm plot. Okay. Next, we have the box plot.
Abhishek, in the last graph, this hue is equal to size. What does that mean? I didn't get that.
Hue is equal to size. So setting hue is equal to size is going to add another dimension to your graph. As of now, if you see here, we are plotting on the different days how much tips are coming. Okay, clear? But if I want to see another column into this, like, so okay, so on Thursday, so most of the people are giving $2 tips, few are giving 4. But what in this, what is the number of people, like this particular person came in a group of 2 or individual or 6 or 10, what? If you want to do that, so if you want to add another column into this graph, you can add using hue attribute. Okay. So if you are setting hue equal to size now, it is giving you day versus tip data, as well as it is adding another dimension size. So with this color now, you'll be able to identify that the people who are coming in a group of 2, like most of the people are coming in a group of 2 on all the days. More people are in 2 group, means in a group of 2 people. Okay.
Okay.
So this size is part of the table already.
Size, which size?
No,
Yeah,
huge size is
size is the column of your data.
okay.
Okay. Next, we have this box plot. To get the box plot, we can use the box plot function directly. We can set the x and y column and data is equal to tips we are passing. Now, what this says again, so in this we have, this is the whiskers, and these boundaries are called the interquartile ranges. This is called the mean value. This bar in the inner box, you can say it is the inner value. These points we say the outliers. Okay, these all are the whiskers. Clear? Now, so what is the use of the whiskers, or what is the interquartile ranges? What is the 25 percentile, 50 percentile, or 75 percentile? Those all things you are going to learn into the stats classes. But yes, one idea I can give, that from this graph, what you can understand, that most of the people who are coming, they are giving the tip between this range, and the mean value is around 2 on Thursday. On Friday, most of the people are giving the tip into this range, and the mean value is this around 3. Okay. And most of the people are coming on Saturday, they are giving the tip into this range between little higher than 2, little less than 4. And the mean value is again little less than 3. And on Sunday, most of the people are coming into this range, they are giving the tip in this range, and it is nearer to 4. This mean value is nearer to 4. Clear? Fine.
Vijay, can we combine a few graphs?
You want to combine Thursday and Friday?
No. This box plot and swarm plot that we did, can we have it in the same plane?
Yes, we can combine. For example, this is the box plot, and we can combine the swarm plot also here. Okay, so I'll be making it into the, let's say, black color or blue color. Let's see, it is coming into the blue color. Okay.
Okay.
One minute. Okay. Next, we have the Valiant plot. So, how we are going to get the Valiant plot? So, instead of box plot, I'll be using the Valiant plot. Okay, x is equal to day, y is equal to tips, data is equal to tips, and this will be giving me the Valiant plot. Valiant plot also, so this is the whiskers, which you can see, the thinner arrow, and this one is the interquartile ranges, the thicker one. Okay, and this dot in the middle, you can see it is the mean value. And this distribution, which you can see, it looks like similar to the KD distribution, which also says that most of the people who are coming on Thursday, they are giving you the tips between this range only. Okay, fine, or in this range. Similarly, on the Friday, on Saturday, and on Sunday. Okay, the mean for them is similar to whatever mean you have seen here. Okay, fine. Clear?
Yes, Vishek.
Okay. So that's it about the Seaborn. Rest all we are going to discuss. There are the different other plots also. Like we have the pie plot, we have the bar plot, we have the count plot and all. Those all things we will be discussing into the case studies. Okay. I'll be discussing the case studies like Titanic and the COVID case studies next week. And probably we'll be covering few other plots and few other analysis we'll be doing there. Okay. Fine. So that's it for today. I'll be stopping the discussion here and we'll be meeting next week. Probably by Saturday, your classes will get over.
Abhishek, can you quick summarize these plots, different plots, subplots?
Okay. So we have we have started with the Matplotlib. In the Matplotlib, we have started with the inset graph, how we can set the inset graph. So we have to set the axis accordingly. If you don't want to set the axis, then we have the subplots function, which will be automatically setting the axis. Okay. Then we can create the multiple rows and multiple column using the subplots function, which we have done here. And it follows the zero based indexing. Okay. And you can do the plotting. Next, we have seen how we can set the figure size and the DPI, and then how we can save the images using the savefig function. Okay. Finally, we have seen how we can set the legends and levels, and last we have seen color, line style, line width, and the marker into the Matplotlib plots. Okay. Then we have moved to Seaborn. So these all are the functional approach. Next, we have moved to Seaborn. And in this Seaborn, we have first initialized our analysis with the univariate analysis, where we have taken one variable and we are plotting it. We are seeing the distribution of the single variable. So that is using the dist plot function. That gives you the histogram, combination of histogram and KD plot. Okay. And in the histogram dist plot, if you want only the KD, then you can set hist is equal to false, or only the histogram, then you can set KD equal to false, and accordingly you'll be getting the graph. You can use the rug plot also inside the dist plot using rug is equal to true, or to get only the rug plot, you have the rug plot function as well. Okay. Fine. Next, we have seen the bivariate analysis, where we have used the joint plot function. In the joint plot function, we are going to pass two variables. That's why we say it is the bivariate analysis, where we can set the x-axis and y-axis ranges also, and we are setting the color. Okay. Now, finally, we have seen the correlation function here. So you can find the correlation between the different columns using cor function, and that we have plotted using the heat map. So heat map plots the correlation between the different columns. In the heat map function, we have passed the correlation object or matrix. Vmax attribute we can set to maximum 1, and accordingly we'll be getting the color bar here. Square is equal to 2 will be plotting this one, like this data will be coming into the square bracket. And not is equal to 2 will be giving you these values. Format is equal to till what decimal point these values will be represented, and CMAP is equal to reds the color of the graph. Okay. Then we have also seen the different types of plot into the joint plot, where you can set the kind is equal to hex and kind is equal to KD. You'll be getting the hex bin plot. This is called the hex bin plot, and this is the KD plot of the bivariate analysis. Next, we have seen the linear relationship, where we have seen the LM plot, where we are plotting the regression line. Okay, and we are again here, it is a linear relationship is the bivariate analysis. We are passing two variables. Okay, here we have the confidence interval. The confidence interval is lower, it means the values are more scattered here, and confidence interval is higher, it means values are less scattered here. So confidence interval will be lower if this strip is thinner, and confidence interval will be higher if this strip is wider. Okay. Next, we have the LM plot where we can set another attribute call. So for if you'll be setting call attribute, then for every value into the type 1 column, you'll be getting the different plots. And you can set the hue attribute also. Setting the hue attribute will be adding the another dimension to your graph. Okay. Finally, we have seen the reg plot. To get this linear plot, you can use the regression plot also, or reg plot also, which will be giving you the same data. Next, we have seen the joint plot, where we can set the kind is equal to regression, which combines the regression plot and the scatter plot. Next, we have the categorical plot. So we have read the data from the Seaborn library itself. And in the categorical plot, we have strip plot, swarm plot, box plot, and Valiant plot. We have seen the strip plot where you are getting the data plotted on the different days with respect to tips. And this is the strip plot we have got. Next, you can set the jitter is equal to true, and you can set the figure size also higher so that you can see the individual points individually. And swarm plot will be plotting the every data individually by default. Okay, so any of the plot you can use. And then we have also seen that in the swarm plot you can add another attribute hue is equal to size, which is adding the another dimension. So for every size of people who are coming, the data will be shown here. And then we have seen the box plot where we have combined the box plot with the swarm plot, where you can see this box plot. In the box plot, we have few things to discuss yet, which will be discussed in our stats class, which are your whiskers, interquartile ranges, and mean, median. So those all are the statistics discussion. But one thing we can understand from here, that whatever this box is coming, it means the values are lying, most of the values are lying into this range, and this is the mean value of this. Okay, these all are the outliers which are coming outside of the whiskers. Okay, and then we have seen the Valiant plot. This Valiant plot, again, it shows the same, that most of the data are falling into this range. This is the interquartile ranges. These all are the whiskers, the thinner line, and dot is the mean. Okay, fine.
Thank you.
Abhishek, like you have shown for Matplotlib, right? These figures for Seaborn can be saved as well in the same manner.
Yeah, you can save them as well.
Okay.
You have to set the figure attribute only. Figure is equal to plt.subplots. Figure comma access.
Oh, okay. Okay. Thank you.
Abhishek, this COL, jitter, etc. These attributes are available for every subplot, every type of plot, right?
If you want to see for which plot it is available, you can just do the shift tab. Okay.
Okay, fine.
Wherever it is available, you can use that.